Good evening, everyone. First of all, I would like to introduce myself. My name is Shanbor Langshiang, and I am from IT departments of second semester of Northeastern Hill University. So, my roll number is 24 BTech IT 31. So, the topic that I would like to share to you all, and also as a part of my assignments of engineering mathematics 2, is wronskian. So, what is a wronskian? The wronskian is a mathematics determinant used to analyze the linear independence of a set of a function. So, let's see a solutions of differential equation, for example x y x bracket equal to c1 y1 x plus c2 y2 x plus continue to until ck yk ck yt k x. This is k. It is a solutions. It can be a sums of different equation. All these valid solutions of k valid solution to the same differential equation. I have been saying that these solutions of a square a 2y double prime plus a1 y prime plus a naught y, it is equal to a of 1 x plus fx bracket x. This is y p1 x y b x1. It should be a linearly independent. I was just saying independence, but actually what I mean was that these solutions are similarly linearly independent. So what do you mean by linearly independent? Linear indi linearly independence of two function or two solution simply means that these two solutions are not constant. Multiples of each others, or k kinds of versions of each other. These are really different solutions which have been differentiate it, and we really get a different meanings out of each solution for the given systems or given differential equation. Now the big questions: how do we claim that a solutions of y1 and is solutions of y2 are linearly independent of each others? So this is something that we maybe it will get different time. We may be asked to show that you have presented this multiple solution. It show where these solutions are also linearly independent to each other or not. So this is something called a wronskian. Wrong is key in wronskians. A wronskin is we did not but the blue the determinants of a particular type, and for example that only two solution is y1 and y2 that we wanted to show that this linearly independent to each others. The wronskin for two function will something like this. We will have something like this. We will have the first element is y1 and the second one will be y2 plus this one will be and this one will be y1 prime and this one will be y2 prime. And for these two equations to be linearly independent, the condition is that the determinants did not equal to 0. If these determinants come out to be 0, we said that these two functions are linearly dependent of each others. In other words, these two solutions are not good for us. These two solutions, y1 because this y2 or this is y2 not y1, this y2 are just different versions of the same function, and we will not interest that in similar versions of same solution. In terms of graph, this is graph. Let me give you example for this word. This was, you know that this is y1 and this one is y2. You can say that these two functions look like very similar, and this make a linear independence on each others. But what if I have another function? This is another function. Continue this. This is another function. This is another function like this. If this one is y1 and this one is y2, there is no way that I could trust from y2 into y1 by simple multiplication. So that means that these two functions that are so different that linearly independent of each others, and if for these two function is, if this one is, as I have mentioned, y1 and the another one is, this one is y2, these two function, I could do the calculation of the wronskins of the calculation of the wronskins of W. You can write W. The answer will definitely be the answer calculation, this one, the answer could definitely not equal to 0. So wronskin is the determinants which have been determines two functions are linearly independent. from each others or not. So thank you so much.